Hello Algebra 2 students. This is a video for example 4 for section 1.2. I want to remind you of the vertical and horizontal stretch and compressions because it comes up in this next section. It's a vertical stretch if k is out here as a multiplier of the function. It's a stretch if k is greater than 1, and it's a compression vertically if it's between 0 and 1. And horizontally, it's a stretch if k is a multiplier of x, and it's a small number between 0 and 1, and it's a compression if it's greater than 1. Because in example 4 we have a combination of transformations. So everything we've learned in the first 3 examples comes into play. The graph represents y equals f of x. It's kind of a weird graph. It's got a bunch of pieces. Using this graph, how can you graph a combination of transformations? So we want to have the x plus 2 come in, if you remember what that kind of a transformation is, and negative as a multiplier. First of all, we have g of x equaling the f of x plus 2, which is a translation of f 2 units to the left. So they've taken the f function and slid it to the left 2 places. That's what we have first. And now we're going to bring in the negative aspect of it. And when it's a negative, as a multiplier, a negative 1, you recall, is a reflection across the x-axis. So this g function gets reflected about the x-axis, and here's the result. So here's our h function in the end. The graph of h is a translation of f2 to the left 2 units, and then a reflection in the x-axis. Okay, what was this study tip? It's easier to perform one transformation at a time, definitely. That's what we did here. We did the x plus 2, and then we did the negative. Let's see what we have here. We're starting with the same graph of f. This time we want to graph y equals 1/2 as a multiplier, f of x, and then the whole thing is plus 3. So let's see what we would start with. Do you start with the half, or do you start with the plus 3? You start with the 1/2. 1/2 is a multiplier. That means we have a vertical compression by a factor of 1/2. So all these points here gets, instead of at 2, it's at 1. Instead of at 4, it's at 2. Instead of at 3, it's 1.5. And instead of at, I think that's 7, it gets dropped down to 3.5. It's a vertical compression, which you can remember from that first screen I was on. Then we got to go to plus 3. One of the easier transformations I think we have to deal with is when it's a plus 3 or a minus, when it's adding or subtracting a value. This is just a translation up 3 units. So from the green g function, we go up 3 to the h function. Now it's going to get a little more difficult. Why? Because I think this is usually more difficult for students. What to do with that 2x. Now if you recall, that 2x being here is a compression. And what I like to do is, when it's a multiplier of x, I like to write 2x equal, and then I look for the x value is 1. So I'm going to have the same value here. What is that? That's 7. I'm going to have a value of 7 wherever x is. Let's see. I'll show you what I mean. I'm going to divide by 2, divide by 2, and I'm going to have an x value of 1/2. So for my new function, my g function is going to be for an x value of 1/2. So at 1/2, I need to be as high as 7. So that's right here. And then let's say I want to find out where this point goes. That's at negative 4. So I write 2x. 2x equals negative 4. Divide both sides by 2. In fact, it's always dividing by 2, and that's a key. Negative 4 divided by 2 is negative 2. So I know that for my new function, when x is negative 2, right here, it's going to equal the same as it did when it was negative 4. So that's a dot right here. And maybe you notice, because it's always been divided by 2, it's cut in half. This moved halfway. This is going to move halfway to here. This point's going to move halfway to here. but I could do it using the same method that I used here if that made sense to you. Okay, now that's only this part. All I've done is f of 2x. It's gone to here, up to here, down to here, up to here. And now I need to do a translation of -4. Do I have enough room? Hopefully I have enough room to drop it 4. Let me change colors for effect. Oh, let's go blue. And maybe with a larger pencil. Down 4, so 1, 2, 3, 4. I'm down to here. And this one gets dropped down 4. 1, 2, 3, 4 to here. This one, 1, 2, 3, 4 down to here. And this one gets dropped 1, 2, 3, 4 down to here. That's my final graph. I got to go back to the Savas site to see if my answer, it might be, let's look at some of these points. This is at -2, -2, and then it hits -1, 0. -2, 2, and then it hits 1, 0. Yep, looks like I got it right. Not that simple, but maybe you like the strategy that I use. So I'm going to use that same strategy for this one. Our last example. Shoot, that was a try it that we had before. I apologize. I should have let you try it first. See if you can use the same strategy that I just used, but now it's 2x minus 3, and then there's a -2. Go ahead and click pause and try it on your own and come back when you're ready. All right. This 2x minus 3 instead of x. So what I'm going to write is 2x minus 3 instead of x. Now, I'm going to start with this x value of 1, and I'm going to see what the x value needs to be for my new function, my g function. That will be 7 units high. So I add 3 to both sides. Still getting used to the cursor on this. 2x equals 4. Divide by 2, and I get x equals 2. So that means in my new function, where x equals 2, 1, 2, it's going to have a value of 7. Okay? Let's try this point. Let me erase. And I'm not going to do that great a job erasing, because just to save some time. But now, instead of it being 1, I want it to equal -1. The x value is -1. So I need the 2x minus 3 to equal -1. And when I find out what that value of x is, I know it's going to be this position here, 3. I don't know where it's going to be, but it's going to be 3. I'm going to add 3 again. I guess I could have left that. It's always going to be add 3 as the first step. And I get 2 for that. And this is 2x. Divide both sides by 2. And I'm getting x equal 1. X equals 1. So for my g function, at 1, it's going to have a value of 3. So now I have 2 points. If you're kind of getting the hang of this now, why don't you click pause now and try to figure out where these two go before I do it. Come back and click pause. Click play when you're ready. All right. Get rid of this stuff. I'm going to try the next point. And instead of -1, I'm now going to try an x value of -2. Let's see where it's going to equal 4. But I need it to be where the x value is -2. -2. I'm going to add 3 to both sides. And I get 2x equals 1. Divide both sides by 2. And I'm getting 1/2. So for my g function, when x equals a half, it's going to equal, oh yeah, I'm doing this point here, right? Yep, it was -2. I plugged in a -2, and I figured out x was a half. So for a half, it's going to be right here. Okay, one more to go. This one here, this one is at -4. So let's plug in -4 into this. And then we're going to add 3, and it's going to change this number. We're still going to divide by 2. All right, let's see what we get. This was -4 was the x value. When I add 3 to both sides, I get -1. When I divide both sides by 2, I get -1/2. So when the x value for my g function, when x is -1/2, it's going to equal what the original f function did at -4, which is 2. So -1/2, 4. I mean -1/2, 2. So this is the g function I'm getting. I'm getting it to go up to here, down to here, and up to here. Now, that took care of this. So that was, I tried to do a g function equaling that, and now I'm going to do the h function, which is just to subtract 2. Let me change colors for effect. I don't know how well green shows up. We'll give it a shot. -2 is just dropping it down 2. So 1, 2. It's going to be here. In fact, let me change to a thicker marker. Right here. It's actually a highlighter. Down 2 to here. Down 2 to here. Down 2 to here. So here's my final answer for the h function. Let's see how I did. It's going to go through 2, 5, 2, 5, and 1, 1, and then go up and down. 2, 5, and 1, 1. 2, 5, and 1, 1. Went through 2, 5, and 1, 1, and then came up and down. Yep, so that, I think that is what I had. And that's how you do those kind of problems. Let's see what you have for an assignment. There's only one problem in the book to do for this, number 28. That's it for this video. Have a great day.